Okay, today's notes will be on 6.6, function operations. So for our first example here, we are going to use the function f of x equals 4x plus 7, and g of x equals the square root of x plus x. Okay, and so our function operation that we are going to look at would be addition. So you're going to see some problems written in a form like this. So f plus g of x, and that's telling you need to add the functions f of x plus g of x. This would mean the same thing as f of x plus g of x. So a lot of students, that notation makes sense to them, that would mean to add those functions together. But this one's a little bit different. I guess you could think of it as, here's function f and function g, you're adding them together. Your input is x, which is what your input is for both of those. So I'm going to go ahead and take f of x, which is 4x plus 7, and then add g of x, which is the square root of x plus x. Okay, so basically all I'm doing is combining any like terms that I have. So that would give me 5x plus 7 plus the square root of x. I can't put anything else together, so that is my answer. I have added the functions together. You will also be asked about what the domain would be for your function. Okay, so when we've talked about domain in the past, sometimes it's helpful to look at a graph. Otherwise, we need to think about the restriction. So is there anything on my inputs or my values for x's that we couldn't have? There are no restrictions for my first x. All right, I can multiply any number by 5 I want. I do have a restriction on x in a square root. I cannot plug in any number I want inside of the square root. That can only be a positive number. So that means all the values for x that I would plug into this function would have to be greater than or equal to 0. Okay, so that would be, why can't I scroll down? Adding. You will also do subtraction as a function operation. That can be written in the same way, but it would say minus, so f minus g of your input x. We're going to use the same functions as above. But now what I'm doing is I'm taking f of x minus g of x. So pay attention to which function is listed first. So f is listed first, so I must take 4x plus 7, and then I'm going to subtract g of x. If I just wrote it the way I have it written right now, I'm going to get this problem wrong. I need to make sure I am subtracting the entire function of g of x, which would be the square root of x plus x. So I need to put that in parentheses so that I make sure I am subtracting the square root of x and I am subtracting x. Okay, from here I can combine my like terms again. I'm taking 4x minus x, which would be a 3x, plus 7 minus the square root of x. That's still all I can do. So there's my answer for my subtraction, and then we will also figure out the domain. So typically we have all real numbers for our domain unless we've got some square roots, which we do. So that means x must be greater than or equal to 0. Okay, so we've looked at addition, we've looked at subtraction. We'll look at 2 more operations, but I'm going to go ahead and switch up our functions. We're going to change f of x is going to be 3x squared minus 11x minus 4, and g of x will be 3x plus 1. Okay. And so now what I want you to do for your function operations, I want to do f times g of x, or also f of x times g of x would mean the same thing. So I'm going to take 3x squared minus 11x minus 4, since that is f of x, and I will multiply it by g of x. Okay, if I leave it written like this, I'm truly not multiplying those functions together. That really only means I'm multiplying the negative 4 and the 3x together. That's not the case. I'm taking the entire function times the other entire function. So make sure you're working on using parentheses here in our function operation problems. Okay, so we're going to be doing a lot of distributing. We are not doing FOIL. FOIL only works if you have two binomials. I have a trinomial on the left and a binomial on the right. So FOIL does not work for everything. So not a huge fan of FOIL myself. So I need to make sure I take 3x squared times 3x. So that would be 9x to the third. I need to make sure I take 3x squared times 1. So plus 3x squared. Now I need to make sure I take negative 11x times 3x. So negative 33x squared. I need to take negative 11x times 1 for negative 11x. I need to make sure I take negative 4 times 3x, so negative 12x, and negative 4 times 1 for negative 4. So make sure you distributed everything. All three of these terms, each of them must multiply each term on the right side. Okay, so we kind of get a lot of stuff, and then we're going to go ahead and combine any like terms that we can. I don't have anything else that's to the third power. I can take my 3x squared minus 33x squared, so that would give me a positive 30x squared. Negative 11x minus 12x would give me negative 31x minus 4. I've combined all my like terms. That's all I can do. I've multiplied everything out. So that would be my final answer, as simple as I can make it. And then for our domain, this time I do not have any square roots. All I'm doing is raising x to the third power, second power, and multiplying it by negative 31. So there are no restrictions on that. So that would be all real numbers for my domain. It does not matter what I would plug in for x. Let's look at our last operation, right? We've done addition, subtraction, multiplication. You could probably expect we are going to do division. Okay, so you may see it like that. You may see it written as f of x divided by g of x. Okay, make sure you pay attention to if I did put g of x over f of x. All right, make sure you pay attention to which function is supposed to be on top, which function is supposed to be on the bottom, because that could be changed from problem to problem. Okay, so f of x, I'm using the same functions as I did above for my last problem. So I am putting the 3x squared minus 11x minus 4 over my 3x plus 1. Okay, and then from here I need to see if I can simplify. Now this should look familiar, hopefully. This is from our last unit. How did we simplify something like this? Well, we factored it to see if there were any common factors that I could divide out of the top and bottom. So I'm going to go ahead and attempt to factor the top. The bottom can't be factored. There's no greatest common factor. It's not written as something squared. So on top, if it's multiplying to 3x squared, I'll need a 3x and an x. We are multiplying to a negative 4. Now, there are no two numbers that multiply to negative 4 but also add to negative 11. That doesn't mean that this can't be factored. Remember, when I have this 3 here, I'm going to have to multiply that 3 by whatever number I put there and then add it to the number I put here. And that will give me negative 11. Okay, so my options would be 2 and 2 and 4 and 1. Okay, so I might need to try a couple things first. Obviously, one of them needs to be negative and one of them needs to be positive. I'm going to do a little bit of cheating, maybe you would call it, because the whole point of being able to simplify this, if I couldn't simplify it by factoring, I wouldn't need to factor. So I want to be able to get rid of 3x plus 1. So I'm going to go ahead and guess that that's 3x plus 1. And so if I'm using a positive 1, I would have to use a negative 4 to multiply to negative 4. Okay, if this doesn't work, it is not worth factoring for this situation. All right, so I'll go ahead and make sure that checks out. So I would get 3x squared, 3x times negative 4 be negative 12x, 1 times x plus 1x, there's my negative 11, and minus 4, perfect. Okay, so it did work out, so that means I am able to cross out my common factors of 3x plus 1, so then I will get x minus 4. Okay, for my domain, now if you look at this, you'll say, yep, all real numbers, I can subtract any number I want by 4. True. But we need to think about the domain from the original problem, right? Originally, there was something in the denominator. We have restrictions on denominators and we have restrictions on numbers in square roots. So I cannot have a 0 in my denominator. That doesn't mean I can't have 0 for x. Some of you got that confused in our last unit. If I plug in 0 for x, I get 1. I don't get 0 in the denominator, I get 1. So it's fine if I plug in 0. I need to figure out what value of x would make that 0, because I can't have that number, because that's what's going to make my denominator 0. So if I subtract 1, divide by 3, x could not equal, so any number but negative 1/3, because that is the only number for x that would make my denominator 0 anywhere throughout the problem. Okay, so a lot of this that we're looking at today is review. We're combining like terms, we're factoring, we're distributing, we're talking about domains. It's a lot of review, but kind of a lot of things that students struggled with in this review. All right, so we've looked at our 4 operations that you're probably already familiar with. We're going to add a new operation that you probably haven't heard before, and that would be composition. So composition is written in a couple different ways. So if I say composition of functions g with functions f is written as g, and it's a little open circle. It's not a degree symbol. It's not a dot for multiplication. Okay, it is a small open circle is the symbol. And that symbol means composition. We'll talk about what it means that you're going to do. So just like when I saw before, right, you've known for a long time, when you see that plus symbol, you know that means to add. Or when you see a division symbol, you know that means division, because you've done that for years and years. Okay, here's our new symbol. That is going to mean something else for us. It's called composition. Whoops, too high. So we'll see some problems, and so let's try a few examples here. So let's say we've got f of x, and that's x minus 5, and g of x is x squared. I'm also going to write another way I could write this is g of f of x. Both of those would be correct forms, so you may see both of those things. I tend to see this form a little bit more often in our more advanced books. You'll definitely see that form in your homework, but I see it in pre-calculus books, college algebra books. This is my preferred form. To me, this makes more sense, so I always rewrite it that way. So this is telling us we're starting with g, and we are plugging f of x inside of g. And so I'll show what that looks like in the next example we're going to do here. So we are going to find g of f of -3. Now, a lot of students think that -3 out there means we are multiplying by that -3. It's going to mean the same thing as it meant from the very beginning, but we had x before. Right, so some of the first problems that we did, we weren't multiplying by this x. That is our input. That's what we're plugging in, or we're just keeping it as x. So now my input is -3. You'll see this form, but I prefer to rewrite it. So I'm starting with g, and here's what I'm plugging inside is f since it's on the inside. What am I plugging inside? I'm plugging -3 inside equation for f. So this is telling me, well, let's find f of -3. When I look at my function above for f of -3, I'm replacing my x with -3, and then I would take away 5. So I would get -8 when I find f of -3. So if I know f of -3 is -8, then I'm going to go ahead and replace f of -3 with -8. So then that means I'm taking g of -8. When I take g of -8, I am replacing the x inside of g of x with -8. So whenever I plug something in, what do I do to it? I square it. So I'm going to square -8, so I get a positive 64. So composition will be taking, you plug a function into another function. Okay, that's our composition. We'll do one more example like that. I want us to find f of g of 4. Okay, if you want to rewrite that in its other form, you can. F is written first this time, so that is my on the outside of the outer function. G is on the inside. And what am I plugging in place of the input for G? I am plugging in 4. So I'm first going to figure out what is G of 4. Right, what is G of 4? Well, I need to look at my function for G. Which is I need to take 4 and square it. So 4 squared would be 16. So since G of 4 is 16, I'm going to replace what's inside here as G of 4 with the value 16. All right, that is the value for G of 4. So now I'm finding f of 16. So I should be plugging in 16 in place of the x in equation f. So in equation f, what do we do? Well, we take whatever number I'm plugging in, and then I subtract 5. So I'm going to plug in 16 and subtract 5. So I get 11 as my final answer for f of g of 4. Okay, so you'll have composition where you can plug in a number. You will also have composition where you would be asked to find the equation. So f of g of x. Okay, this is a little bit more abstract. Okay, because I don't have a number that I'm plugging in. I'm plugging in the entire function g of x in place of the input in f. Okay, so what is g of x? Well, g of x was x squared. So that's what I'm plugging into f. And f was written as x minus 5. Instead of x minus 5, I would write x squared minus 5. I replaced its input with x squared. So that would be the equation for f of g of x. Okay, if I asked for the other way around and I said find g of f of x. Okay, now I'm doing the reverse. I am taking f of x as my inner function, and I'm going to replace the input in g of x. So what am I plugging into g of x? I'm plugging in x minus 5. Okay, in g of x, my equation is just x squared. So that means where I see the x squared, I'm replacing that x with x minus 5. Right, so I have an input squared. Normally that would be x, but what am I replacing it as? X minus 5. So in some cases, it's fine to leave it as x minus 5. In other cases, you are welcome to, multiply that out, distribute it. So I'll get x squared minus 5x plus 25. So I'm fine with this answer at this time, or minus 10x plus 25. There's certain cases where it's good to have it in this form, and other cases when it's good to have it in this form. So right now, I'd say either one is fine. And we'll talk about more why one would be better than the other. Okay, but that would be composition of functions when we do not have an input that we are plugging in a specific number. Okay, all right, we're going to take a look at one more example here, and we are going to do a word problem using composition. Okay, so let's say you have a coupon good for $5 off the price of any large pizza. You also get a 10% discount on any pizza I'll just end it there. I was going to say, if you show your student ID, we don't care. So then I'm going to write, how much more would you pay for a large pizza if the cashier applies the coupon first? All right, so here's what we're going to do. We are going to create equations here. So we're going to create an equation for the cost using the coupon. All right, and let's say we'll use X as the price of our pizza. So I'm going to use C for cost. My input is X for the price of my pizza. So whatever the pizza's price is, my coupon's $5 off. Okay, cost using a discount. So I'll use D for discount. Pizza is my input. My discount is 10% off the pizza. Many students will want to say 0.10x, okay, because they'll realize 10%, I'd use 0.10 as a decimal, multiply it by the price of my pizza. That will tell you how much money you would get off of the price of your pizza. So you are taking 10% off the value. So if you're taking 10% off the value, you could also rate it as, well, I'd take the price of the pizza and then I'd subtract how much money I'm getting off of that pizza, or I would take a whole minus my 0.10 and I would have 0.9, or I'm paying for 90% of the original price if I'm taking 10% off. So that would be my short way to write that. Okay, so setting all that up, the whole point of this is to use composition. So we're going to use composition with the discount first. So what that would mean is that I'm going to apply the discount first. So the discount will be on the inside of the cost function. So I'm taking the discount function, which is 0.9, I'll just use 0.9x. I must replace the input in the cost function. So that would be 0.9x minus 5. Okay, let's write composition with the coupon first. So I'm applying the coupon function to the inside that's being applied first into my discount function. So my C of x function is x minus 5. So that means I'm taking the $5 off first. The one above, I took the 10% discount off first. Okay, so that means I need to replace the x in my discount function with, instead of x, it's going to say x minus 5. So 0.9 is multiplying x, but instead I'm putting it as x minus 5. Okay. One reason why we go over these word problems, sometimes I have students that get angry with me and they say, well, I could just figure this out without setting up all these complicated equations. And yes, you probably could. I could create a harder word problem where this would, be applied a little bit more than this situation, but this situation should hopefully make sense. And when we apply it, it should hopefully help you make sense of what composition is really doing when we apply it to something that's a little bit simpler and something that you would be familiar with, right? You've all purchased hopefully something in your life with either a coupon or a % off discount. Some of you work in these industries where, you have to plug in these things in your cash register, okay? And there are benefits to when things are applied first. And you might have restrictions in a certain store on which can be applied first. Okay, so taking a look at this, if I distribute this, it might help you see a little bit better which one would be better. So 0.9x minus 4.5. Okay, so when I look at this, no matter what, when I take my 10% discount, that's going to give me the same price every time, but I'm going to take $5 off, and here I'm going to take $4.50 off. Now for me, I'd rather take $5 off than $4.50. So it is going to be better when my discount is applied first. I will save more money, even though I have the same two coupon and discounts happening. It does matter which one's applied first. The question asks for what's going to be the difference. So you can logically think about it. Some of you already know the difference is 50 cents, right? But you could also subtract these functions, which then is applying our operation of subtracting two functions. So the parentheses doesn't matter for the first one, but it does matter for the second set, and I need to make sure I would change that to plus because I'm subtracting a negative. So those cancel out because it's the same every time. And then I would take -5 plus 4.5. So I'd be left with -0.5 because the difference is 50 cents. okay? I would have to pay 50 cents more if I applied the coupon first. All right, so you will have a problem in your Math Excel assignment, but they're going to give you these functions, and then we'll talk more about these problems and look more about what I will ask you to do for your test. All right, that is it for our lesson today.